Hi everybody, welcome back. So let's do a few example problems to help you get used to doing problems with density. So with that in mind, I've pulled some from my old PowerPoint and we're going to walk through them together. So it says you've been working in the laboratory to develop a new material called Dr. S45. A cube, that's important, possibly, of Dr. S45 has a density of 250 pound mass per cubic foot. Now what is the specific gravity of Dr. S45? Okay. Not too terrible problem, and usually the numbers work out pretty nicely, so not too much math to do here. Now, first off, what is the equation for specific gravity? Well, specific gravity is equal to the density of our object over the density of H2O. Density of H2O is something you should know. You can look it up in your book, you can look it up online, and you always want to look it up in the units that your problem has. Because I could do this in kilogram per meter cubed and solve for the density in kilograms per meter cubed by converting everything. That's a lot more work. Just look it up. And so the density of water in pound mass per foot cubed is simply 62.4 pound mass per foot cubed. So with that, if we look at this, I can plug everything in and I can solve my problem. So I'll erase this little line right here, and this would be equal to 250 pound mass per foot cubed. I'm writing out the units because I want to make sure I don't make a mistake. Over 62.4 pound mass per foot cubed, and that would be equal to roughly 4. So specific gravity of 4. This is probably some sort of liquid, a fairly viscous liquid. But there you go. We have it. You've solved this problem. I made a mistake when I said viscous. I should have said dense, a dense liquid. Viscosity and density are completely different. Okay, and now let's check myself. But first off, specific gravity, density of the object over density of water. Plug in our numbers, we get a value which is 4. Cool beans. I hope this helped you. See you later. And let's check. And it's 4. Fantastic. I have everything covering the screen, which is terrible, but it worked. I got the answer right. Okay, let's try out one more problem. So what is the mass of 2 gallons of liquid bromine in units of pound mass? Okay, a little bit different. So 2 gallons, that's probably important. Pound mass, also important. It's asking for the mass. And it says the specific gravity, okay, that's probably going to be helpful, of bromine is 3.12. So we want to get that mass. So first off, let's write out our density equation. Density is equal to mass over volume. We know the volume, we don't know the density. Let's go ahead and rearrange this to solve for mass. So mass will be equal to density times volume. So if we can solve for that density, we can solve for our problem. Now the second thing it gave us was specific gravity. So write that out. Specific gravity is equal to the density over the density of water. Okay, we know the density of water, we know specific gravity. We can solve for the density. So let's rearrange that. Density is equal to density of water times specific gravity. So once I can plug all of that in, what I get is the mass is going to be equal to the density of water times the specific gravity times the volume, which is 2 gallons at this point. Okay, and if we then plug in our numbers, we can solve this. However, I've realized that I don't actually know the density of water in gallons, pound mass per gallons, right off the top of my head. It's roughly 10. So we'll use that for now. 10 pounds per gallon, so 20 pound mass per gallon. We'll see how close I get. Okay, so we'll do that right here. 10 pound mass per gallon times 3.12 times the volume, which is 2 gallons. We plug all that in and we get 20 times 3.12, which would be 62-ish. So equals 62 pound mass. Okay, and considering I guessed here on the whole pound mass version, Let's see how close I got. 52. Okay, it is not 10 pounds. It's a little bit less than that. But the setup would be exactly the same. So you look at here, it actually has all the steps for you. And we see that where did I go wrong? Okay. They converted the volume to meters cubed. They went a very different route than I would have gone. But we could have looked up the actual density in pound mass per gallon to save ourselves some time. What they did was they converted everything to SI, which also works, but you have a couple extra steps then. You have to make sure that you do the volume conversion correctly. And you have to convert back at the end. But it all works out. It's all completely fine. So use this to your advantage. And also, just as a note, I was off because it says that it's 8.5 pound mass per gallon. I said it was roughly 10. Give me a break there. I wasn't too far off. That's where I went wrong. Okay. So I hope this helps you. Look at these problems, try them out, walk through them, and practice using those equations and succeed. You will do well. I believe in you. Have a good day. Goodbye.